Chapter 4.4, Graphing a Function Rule. Your objective for this chapter is to graph equations that represent functions. Okay, so example 1, the question says, what is the graph of the function rule y equals negative 2x plus 1? So the easiest way to graph anything under the sun is to make a table. So we are going to choose some x's. Now these are what you choose, okay? You can choose any x's you want, but the standard x's to choose are the smallest numbers that you can, and generally we choose negative 1, 0, 1, and 2. We always want to choose a negative, we always want to choose 0, and then we choose some positives. So when we plug the negative 1 in, we get, for x, we get negative 2 times negative 1 plus 1. You just figure out what number that gives you out. So that's going to be positive 2 plus 1, which is 3. So my point, when I have negative 1 for x, I have 3 for y. And that's going to be my first point that's going to go on the graph. Then plug in 0 for x, and you get 0 plus 1, which is 1. So when I plug in 0, I get out 1. Then plug in 1. So this will be negative 2 times 1 plus 1, which is negative 2 plus 1, which is negative 1. That's the point 1, negative 1. Next point, negative 2 times 2 plus 1 is going to be negative 4 plus 1, which is negative 3. So 2, negative 3. Now, I'm going to put those points on a graph. The first point, negative 1, 3, I'm going to go from the origin, left 1, positive 3. So I'm going to start at the origin and go left 1, up 3. The next point, 0, 1, I'm going to go left to right, 0, and up 1. Put a point. Next point, 1, negative 1, I'm going to go right 1, down 1. Put a point. The next point, 2, 3, start at the origin, go right 2, down 3. Put a point. Then you graph your line. So we're going to put our line through those. I'm just going to freehand a line. Guided practice number 1. They want you to graph the function rule y equals 1/2 x minus 1. And I put on there that you need to use the coordinate plane for example 1. So you're going to make a table. Your function goes in the middle, 1/2 x minus 1, and you're going to choose some x's. You can still choose negative 1, 0, 1, and 2. Plug those 4 numbers in, pause the video, and I'll give you the points you should get in just a second. Okay, so my points are going to be negative 1, 1.5, or negative 1.5, then 0, negative 1, 1, negative 1/2, and 2, 0. So if I put those points on my graph, I'm going to graph this one in black. I'm going to graph the easy ones. 2, 0, which is going to be right 2, up or down 0, put a point there. Then there's also 0, negative 1, so I'm going to go left or right 0, down 1. And then I'm just going to draw a line between those two because graphing fractions is harder. So 2 points make a line, so I'm going to graph those 2 points and make a line. Your other 2 points should lie on that line if you want to check it. Negative 1 and negative 1/2. It's going to go left 1, down 1.5, which is about there. And then 1 and negative 1/2 is going to go right 1 and down about 1/2. So it works out. I just don't want to have to put the half coordinate on there. Sometimes you're going to have to, and if that's the case, then you just have to do it. But this time I didn't have to. All right. Example 2, graphing a real-world function rule. Just bear with me because real-world functions do not play nice. Their numbers are not fun, and they're a lot bigger and all kinds of stuff. We got a function rule. W equals 146C plus 30,000, and that represents the total weight of a concrete mixer truck that carries C cubic feet of concrete. If the capacity of the truck is 200 feet cubed, What is a reasonable graph of the function? So capacity means that I can't go over 200 cubic feet. So my biggest number that I'm going to have is going to be 200 cubic feet. And then let's just pick some numbers beneath that. So how about 150 or 100 or 50, or let's say there's 0. So if I plug in 0, I'm going to get 30,000. So that's going to be the point 0, 30,000. Then if I plug in 50, I'm going to get 146 times 50 plus 30,000, which is going to be 50 and then 37,300. If I plug in 150, that's going to be 146 times 150 plus 30,000. And that's going to be 150 and 44,600. Oh, that's supposed to be 100. Just kidding. So that's going to be 44,600. If I plug in 150 this time, plus 30,000, that's going to be 150 and 51,900. Then let's plug in 200. And that's going to be 259,200. That's my upper part of my graph. So now I have to graph these points right here on this graph. So I have a first quadrant graph. Since I can't have negative weight or anything, I'm going to do a first quadrant graph, which means everything is going to be positive. And across the bottom, we're going to do the x's. And the x's we chose were 0, 50, 100, 150, and 200. So that's going to be easy. We're going to go 0 there. And then let's do 50, 100. And I'm just skipping 150, 200. Okay, then for the hard part, graphing these numbers, the y's or the w's, we got to go 30,000 up to 59,200. So let's count by 20,000s, but we're not going to count each hash mark here. We're going to skip. So we're going to do 20,000, then 40,000, then 60,000, like that. That's what the K means, is that it's 1,000. Then let's graph our point. So the first point is 0, 3,000. So that's going to go, we're going to start at 0 and we're going to go, 30,000. So we're going to go up to 30,000, which will be here. The next one is 50, and it's at 37,300. So it's almost at 40,000. So we're going to put the point about here. The next one is 144,600, so it's going to be halfway between 40 and 50, so it's going to be about here. The next one is 150 and 51.9, so it's going to be 150 here and then up to 51.9, so there's 50, so it's going to be about in here somewhere. Then the next one is 200, and it's at 59,200, so it's going to be right at 60,000. About there. And that is my graph. Now, because I could have any weight between these weights here, I'm going to draw a line between them that shows that it's a continuous function. But then also, because I can't have more than 200 and I can't have less than 0, I'm not going to draw arrows on this line. It's going to be one of these numbers in this area, but it's going to stop at 0 and it's going to stop at 200. All right, guided practice number 2. Okay, the capacity of the spot is 250 gallons, which means I can't go over 250. That's going to be my most. And that's going to be my number of gallons. And over here I'm going to have the point gallons and weight. My function is 8g plus 700. And I want to figure out what the graph's going to look like. So 0, 50, 100, we'll do 150 and then 250. And I know I skipped 200, but it's okay. Now I want you to plug those in, find your points, and then put them on the graph. And I'll give you the answer in just a second. Okay, so I didn't finish the table because I need you to be responsible for something. So you're going to finish this table right here by plugging in 0 for G and figuring out what the point's going to be. But then I did give you the graph so you could check yourself. So I got 1, 2, 3, 4, 5 points for the 5 X's or the 5 G's you chose. Ignore this point, it's a mistake. So I want you to finish filling out the table and check yourself with the graph. And then we're going to example 3. Before we can do example 3, we need to talk about continuous versus discrete. A continuous graph is a graph that is considered unbroken. So if you think about filling up a bathtub and you turn on the faucet, at any point that faucet is running, you could have any number of gallons in that faucet. It could be a half gallon, it could be a third of a gallon. That would be a continuous graph where you don't have any break between the points. It's just a line. So you put a line through points on a continuous graph. Then you have the discrete graph. Now if you think about that, that's like if you're filling a bathtub up with a bucket and you pour a bucket in every time. So if you pour the first bucket in, you might have this many gallons. If you pour so you might have this many gallons. Next bucket, this many. Next bucket, this many. Next bucket, this many. But you're not going to have between that because you're filling it up with a bucket. So a discrete graph is just points isolated on the graph. And a continuous graph could have points on it, but you draw a line between the points because it's continuous. Okay, example 3. A local cheesemaker is making cheddar cheese to sell at a farmer's market. The amount of milk used to make so that's supposed to say, used to make the cheese and the price at which he sells the cheese are shown. Write a function rule for each situation. Graph each function. Is the graph continuous or discrete? So I'm actually not going to have you graph these. I just want you to tell me if they're continuous or discrete. So the weight of cheese depends on the number of gallons of milk that is used. So I could use any number of gallons of milk that I want to use. I know it's in a gallon-sized jug, but I could pour half the gallon out, or I could pour 2 cups of it out, or whatever. So I could choose any gallon size of milk. So this is going to be continuous. Let me draw. And then the amount of money made from selling cheese. So he's selling wheels of cheddar cheese. Have you ever seen a wheel of cheese? It is 1 piece. And how much money he makes depends on how many wheels he sells. Now, he is going to sell a wheel at a time. People are not going to come up and say, hey, I want a half a wheel of cheese. So, is that continuous or discrete? If he has to sell a wheel at a time, then his money is going to jump with the number of wheels that he makes, and it's not going to be filled in between, because I'm either going to sell 1 wheel or 2. I'm not going to sell a half, so no line between 1 and 2, so just discrete. Alright, guided practice number 3. The amount of water in a wading pool depends on the amount of time the wading pool has been filling. As related by the function, is the graph continuous or discrete? I want you to make your best guess. Make an educated guess. Is it continuous or discrete? And I'll give you the answer in just a second. And it is continuous, just like my bathtub example. They're filling the wading pool with water, and they could cut whatever they're filling it up with, the faucet, off at any moment, so that's going to be continuous. All right, example 4, nonlinear functions. You're still going to make a table for these, so it's not going to be much different. It's just that you're not going to have a line when you make your table. So our table is going to be x, and then our function in the middle. This is called our process column. And then our points, so x, y. So let's choose some x's, -2, -1, 0, 1, and 2. Plug in -2 and you get absolute value of -2 minus 4, which is going to be 2 minus 4, which is going to be -2. Plug in -1. You get absolute value of -1 minus 4, which is going to be -3. Plug in 0. You get 0 minus 4, which is going to be -4. Plug in 1. You get 1 minus 4, which is going to be -3. Plug in 2, and you get 2 minus 4, which is going to be -2. Then graph those points. So for the first point, we're going to go left 2, down 2, right here. The next point, we're going to go left 1, down 3. The next point, we're going to go down 4. The next one, we're going to go right 1, down 3. And the last one, we're going to go right 2, down 2. And that graphed not a line, but a V. Anytime you graph absolute value functions, you're going to graph a V. So if it has those 2 bars in it, they're going to make a V. Next thing we're going to do is B. We're going to make a table again. We're going to put our process column in the middle, which is going to be x squared plus 1. So we're going to choose really small numbers because we want to we have to square these numbers, so I don't want to put 9 in there and get 81 because I don't want to graph that. So -1 squared plus 1 is going to be 1 plus 1, which is 2. 0 squared plus 1 is going to be 0 plus 1, which is 1. 1 squared plus 1 is going to be 1 plus 1, which is 2. 2 squared plus 1 is going to be 4 plus 1, which is 5. Then we're going to graph those points. So the first point, we are going to go left 1, up 2. Next, 0, 1. So don't move left or right any and go up 1. Next, 1, 2. And next, 2, 5. Just up here. Now I know that looks sort of like a V, but if you'll look closely, the right hand side is not a perfect line. It's actually going to be like a curve like this. That's called a parabola. Anytime you graph an x squared function, you are going to get a U, a parabola. Alright, guided practice number 4. What is the graph of the function rule y equals x cubed plus 1? So I want you to make your table and put that on your graph. This is going to make like a little, it's a cubed function, so it's going to make like a little S-shaped and odd little curve. But you're responsible for that. I'm not going to give you the answer. Put that on your paper and then do the guided questions. Okay, slide 3, where I want you to graph each of these. All 3 of them are going to graph a straight line. Make a table and then put it on a graph. Bring it to me tomorrow for proof you did your homework.